So this is the first question. It says else use the LCD to eliminate the fractions from each equation. So what we want is not a fraction, right? So we want something similar. So we know that 3 times 4 is 12, 4 times 3 is 12, 12 times 1 is just 12, 6 times 2 is 12. So let's go ahead and just do that so we can make the entire denominator the same, right? So times this by 4, times this by 3, times this by 1, which is just the same, times this by 2. And remember, whatever we do on the bottom, we have to do on the top, right? So times this by 4 as well. So the top by 4 and this by 3 and this by 1, which is just the same, and this by 2, right? So just 2. And now we get that 4x minus 1 over 3 times 4, which is 12. So 12 minus 3, 2x minus 5 over 12. 4 times 3 is 12. Over 5 times 1 is just 5. Over 12, which is just 12 times 1, which is 12. Plus 2x, so 2 times x, which is just 2x. Over 6 times 2, which is 12. So when we have the denominators the same like this, what we can do is actually just cancel the entire denominator out. So you're just left with the top part. So basically we can just cancel this entire thing out from the bottom, right? So it just never existed, like, so you just get 4x minus 1. Sorry, I forgot to put the minus sign over here. Minus 3, because you don't get rid of the signs though, right? So important thing to remember. So 2x minus 5 equals 5 plus 2x. Now let me just show you why I just canceled the entire denominator out like that and just put it as that. Because once the denominator is the same, you have to multiply to get rid of the denominators, right? So once you have them the exact same, so we have them the exact same, multiply everything, so the entire equation, by 12. So multiply everything by 12. And if we multiply everything by 12, we know that multiplication and division cancel out. So that would cancel out. And we would give the 12 to this as well. And that would cancel out. We would give the 12 to that as well. That would cancel out. We would give the 12 to that. And that would also cancel out. Right? So basically, we can just cancel out the entire denominator once they're the same. And just leave. And that leaves us with the top part. That's it. So that's for A. For B, over here it is 2x plus 3 over x plus 5 plus 1 over 2 equals 7 over 2x plus 10. Okay, so how can we make the entire denominator over here the same? Well, we can multiply this by 2 and this by x plus 5, right? To make them the same. Here, let me show you. So you get 2x plus 3 over, well, multiply this by 2, so x plus 5. Remember, you have to multiply the top by 2 as well. And then plus, and remember, we're going to multiply that by x plus 5, so you get 1 over 2. The 2 still stays, but multiplied by x plus 5. And you have to multiply the top by x plus 5 as well. Whatever you do on bottom, you have to do on top. And whatever you do on one side, you have to do to the other. Now, do you though? For this, no, you don't. Because the point is to make the denominators the same. So we can see that the denominators are the same over here. Because if we FOIL this out, that's 2x. 2 times 5 is 210. So once the denominator is the same, we don't have to do anything. So we can just go ahead and rewrite that. So you get 2x plus 3. And you have plus x plus 5. Because the 1 just cancels out. And equals 7. Now, why I didn't write the 2x plus 5 and 2x plus 10 is because, remember, we can just cancel the denominators out when they're the same, right? Because if we FOIL this out here, let me just rewrite it. So 2 times x is 2x. And then we have to give the 2 to this as well. So 2 times 5 is 10, so plus 10. And same thing goes for this one, so 2x plus 10. And we know that 2x plus 10 is already here. 2x plus 10, right? So now that they're the same, you can just cancel them out. And that just leaves us with the top part over here. So the answer, final answer for this one is just 2x plus 3 plus x plus 5 equals 7. That's your final answer for that. And for C, it says 4x over x squared minus 9 minus 5 over x plus 3 equals 2. Okay, so over here, first of all, let's factor this, right? First of all, we have to factor everything that's possible. So let's go ahead and just factor this. So we know that anything that's factorable over here is only just the x squared plus 9, right? So let's just factor that. So x squared minus 9. We know that this is just x plus 3 and x minus 3. So let's rewrite that in factored form. So you get 4x over x plus 3. And you have x minus 3. X minus 3. Okay. And let's rewrite it. Minus 5 over x plus 3. And you have equals 2. So we see that x plus 3 is already here, right? Let me just make that plus sign clear. X plus 3 is already here. So the only difference is to make this the same, multiply it by a x minus 3, right? Because x plus 3 is over here. Over here, on this side, we're going to have to multiply it by x plus 3 and x minus 3 to make the denominators the same. Because right now, the denominator is just 1. 2 divided by 1, which is just 2. So let's go ahead and let's just do that. And remember, you don't write equal signs when something is not equal to something. You just draw an arrow to representing what you're doing. So you get 4x over x plus 3. And you have x minus 3. And you have 5 minus. You have to multiply the x minus 3 on top as well. So you get 5 x minus 3. And you have x plus 3 was already there. X plus 3. Now we're going to multiply by x minus 3. And on this side, we're going to have to multiply. Let me just write down the bottom a little bit. The 2 over x plus 3 and x minus 3. And on top, we have to do the same, right? So x plus 3 and x minus 3. So now, let me just rewrite that on a new piece of paper over here. So you have the new equation as 4x over x plus 3, x minus 3, minus 5x plus x minus 3 over x plus 3, x minus 3, which equals 2x plus 3, x minus 3, all over x plus 3, x minus 3. Okay, now that we have that, sorry, I don't know if you can see the entire thing. Here, let me rewrite it as smaller. So something as smaller.